Alright guys, so we are going to study section 1.3. Don't forget, where there is a red dot, you need to fill up your definition. If in case I forgot something, please realize that you need to fill up the blank also. I may miss some of the blank when I'm doing these videos. So let's jump right away to the section 1 for the example number 1. And we try to understand why to find the x-intercept when we need to set y equals 0. Because when you try to look at the x-intercept, which is the point of intersection between your line and the x-axis right here, so the point of intersection is right there, and right here we're having y equals 0. So when y equals 0, we are going to end up to have 0 equal 2x minus 6. I'm going to add 6 both sides, and when I'm adding 6 both sides, I'm getting 6 equal 2x. Dividing by 2, so we got 2x equals 6. I divide by 2 everywhere, and so now I got x equal 3. So my x-intercept is going to be 3, 0. Now, if I try to do the same thing, but instead for the x-intercept, I'm going to try to look for the y-intercept. Well, the y-intercept is the point of intersection between the y-axis and your line, and right here we're having x equals 0. It is the easiest point to define because when you have y equal 2x minus 6, you end up to have 2 times 0 minus 6 and y equal negative 6. And so your y-intercept is going to be 0, negative 6. The 0 of a function, don't forget to fill up this, and let's go to the example number 2. Finding the 0 of a function, what is it? Well, you just wrote the definition, but you should rewrite the definition anyway because you're on a training session. And basically it is what value of x makes f of x equals 0. So 0 equal 5x plus 20. I subtract 20 both sides. I end up to have negative 20 equal 5x, and then I divide by 5 both sides. I end up to have x equal negative 4. Alright, so now let's go to the example number 2. Oops. And in this example number 2, it's about the constant function. What is a constant function? A constant function is a function that does not change. So y equal constant, that means y do not change. Do not change no matter what x will be. And a function when x equal a constant, well, x do not change, and I could rewrite that another way, when y does. So when I look at the example number 2, I can see right away that when x equal 0.5, y equal 2, x equal 1, y equal 2, x equal 0, y equal 2, x equal negative 5, y equal 2, x equal negative 1, y equal 2. I got a line, and I got when y equal a constant, I got an horizontal line. On the other hand, and let me just make some change because there is a tiny mistake, so I'm going to rewrite my Cartesian system coordinate. So this is going to be my y-axis, this is going to be my x-axis, and I'm going to call that 1, 2, 3, 4, as well as 1, negative 1, negative 2, negative 3, negative 4, and then negative 1, negative 2, negative 3, negative 4, and 1, 2, 3, and 4. Okay, if I want to graph x equal negative 4, no matter what value of y I'm going to have, x will be always negative 4. So when x when y equals 0, I'm going to have negative 4. When y equals 1, I'm going to have negative 4. When y equals 2, I'm going to have negative 4. When y equals 3, negative 4. And the same thing for the negative value of y. When y equals negative 2, I'm going to have negative 4. When y equals negative 4, I'm going to have negative 4. And I can see that I have a line, but this time, this line is a vertical line. So when you have x as a constant, you will have a vertical line. Now, regarding the slope, you don't need to be scared about how are you going to know which point is the point 1 and which point is the point 2. It doesn't matter because you will find exactly the same value. So do not be afraid if you have to calculate the slope with 2 points to decide which point is going to be your point number 1 and which point is going to be your point number 2. Alright, so you can decide to take the point number 1, the one you like the most, and obviously you will know which one is the point number 2 now. So now let's take a look at the slope-intercept form. Don't forget to fill up that, and let's try to find the slope and the y-intercept when you have a graph y equals 3x minus 2. Well, because you know that your line is defined as y equals mx plus b, m is your slope, m is the slope. Okay, I would like to remind you very quickly that when the slope is defined as a variation, a change in y divided by a variation in x, and it's also defined as a rise over run. Okay, so in that case, we're having m equal 3, which is 3 over 1, and if I want to graph this line, I'm going to use the idea of rise over run, plus 3, I will have to go plus 3, and up 3, and then I will have to go 1 to the right because of the plus 1. And from which point? From the y-intercept. What is the y-intercept? We said that the y-intercept, it is when x equals 0. And when x equals 0, I substitute x inside my equation right here, and I'm going to have y equal negative 2. So if I want to graph this line, it is going to be pretty simple. I'm going to plot the point negative 2, 0, negative 2, so right here, that is my y-intercept right there. And from this point, I'm going to go up 3, 1, 2, 3, and 1 to the right, 1 to the right. And now I got my second point. Alright, and now I can graph my line, which is going up, and I'm supposed to have a line going up because m equals 3 is positive, so I'm supposed to have a line going up. Okay, I'm supposed to have a line going up. Let me erase that and present that a little bit better. Okay. Now, guys, it's up to you to do the example 1, section 1.2 linear function. It's up to you to do the example 1 right here, as well as the example 2, example 3. And if I'm correct, you will have to do also the example number 5, A, B, and C. And normally you should be okay. Again, if you feel uncomfortable after the set of problems we would have done in class, it will be up to you to do the practice problem home, and we will be able to talk about that next time. Thank you.